All right, welcome guys once again to another section of learning. Okay, I have a question before me. This question says if cos theta is equals to 4/5, then for 0 degree less than theta less than 90 degree and tan theta is equals to what? Now, if we must solve this question, there is only one thing we need to do here, and we need to understand. We need to understand that this question is trigonometric ratio, and which simply means, in other words, that's generally known as SUKA and the rest. Okay, so for from this 0 degree less than that here means that we should know that we are referring to what I call acute angle here. Okay, acute angle. So, and you know, acute angle are angles that are less than 90 degrees. So if it goes beyond 90 degree, it becomes an obtuse angle. So in this case now, so we are going to do something called acute angle. So if we have something like this, so this is solution now. We are trying to solve this problem. We have this now. All right. Okay, and so we all know that angle at a point is this, and the half of it is semicircle, right? So if I divide this semicircle into two, I've gotten this here. So I can just close it up, become a triangle. So if I extend this one again, it becomes another triangle. So you get that now. So, but we've extracted, just assume we pick the triangle from here and we get the triangle here. So what we do here now is this. Since we are giving sine theta equals to 4/5. So we know what our cos theta is 4/5. We don't know what the answer to do for tan theta, right? Tan theta is unknown. Now something is missing. There are three ingredients. When we talk about sine trigonometric ratio, there are three ingredients, and those ingredients are sine, cosine, and tan. So these are the three basic ingredients. Other ingredients comes in such as we begin to have cosecant, secant, and the rest. You get that now? So for this time around, these are the basic ones. So what I do here now is to see. We need to get that one of the third one that is missing here, which is what? Sine theta. We need to know what is sine theta. Until we find this one, then we can be able to proceed to this. So how do we be able to find the tan theta so that we can proceed to the one exactly we are asked to look for? In doing that now, you should also understand that we have we have the SU, we have the car, we have the tour. So this one means your sine, which is what? Opposite over hypotenuse, right? The cos, the cos theta means what? It means your adjacent. The A here means adjacent, and the H here means hypotenuse. And the next one here, your toa means that's tan theta is opposite over adjacent. I guess that is clear now. So in this case now we can know where this falls in. So if we are doing this, we could consider this place as theta. Okay, all right. These two sides, they are not constant, like it varies, it changes, but this one always remains the same. Now, how do we know this is our hypotenuse? Let's write it there. So if we consider this place to be, if we are using here, this angle here to be our tan theta, that means this one, the side this angle is facing will become our opposites. Likewise, if we remove this here and we choose to make this place our tan theta, it simply means our opposites we no more become here, we no more be here, we become here. This as the side that the angle is facing. So, but I choose to make it, I feel I should make it this way. So here is our opposite side, and here, if here becomes opposite, so automatically here becomes adjacent, right? Of course. So at this point now, you can see that all the side have loaded them and the rest. So the next I want to do here is to see my cos theta, right? 4 over 5. Now, cos theta, which is what? 4. Adjacent is 4, hypotenuse is 5. So I'm going to put adjacent. I'll put adjacent equal to 4. Sorry, 4. 4 here. Then hypotenuse equal to what? 5. So what am I looking for here? I'm looking for opposite. In order for me to get opposite, in this case now, we are going to employ the method called Pythagoras theorem, because this Pythagoras theorem helps us to look for side. So because we have what this side is, we know the value for this side, but we don't know the value for this side. You should know that sine has to be opposite of hypotenuse. So we know hypotenuse, we're looking for sine, but we do not know what the opposite is. So in that case, we need to look for using what hypotenuse. We are looking for opposite using the Pythagoras theorem. So apply the Pythagoras theorem, we have the opposite. We're looking for this opposite. Or probably let me just make the formula. We say we just give it is, which is A, B, C. So which are for the angles, but the side we use small letter to represent the side. So this angle here is B, I'll put small letter B here. This angle here is C, I'll put small letter C here. And this angle here is A, the side is opposing. I'll put small letter A here. So what side am I looking for? I'm looking for B. So what am I going to do here? I'm going to say B square, or let me just give you the formula itself. So it becomes C square equals to B square plus A square, or A square plus B square. Now this is the formula for Pythagoras theorem. Okay, I'm using Pythagoras theorem here now just to look for this side B, which happen to be the opposite. So looking for this now, I know what this one here is 5. That's 5 to the power of 2. All right, equals to what is A? A is 4. You should know that A is 4. The value here is 4. That's 4 square plus what? B. We don't know what this B is. That's B square. That's what we're looking for. So in this case now, what we do here now is to say, we just say the square for 25 is what? Is 4. 5 is 25 equals to the square of 4 is 16, and this is here. So I could just say that 25 minus, if this 16 plus 16 comes to this other side, become minus 16 equals to B square. Or in other words, I could write it this form here. I could just put it this way. Okay, so I just turned it. So in this case now, what do I have next? I have 25 minus what? 16. That's giving us what? 9. So I'll say B square equals to what? 9. Right? Is it 9? B square is 9. So in getting what B is, don't forget we are looking for B, not B square. So in finding B, I would say equals to 9. I can square both sides. So squaring both sides equals to 9. So these two here have eliminated the square root, which is square root both sides. Then become B equals to 9. This equals to square root of 9. The square root of 9 is what? Is 3. So you can see that B is what? Is 3. 3 will be here as our answer. So from here now, I believe this is very clear. All this one is Pythagoras theorem we use in getting this. So we've gotten what all the sides are complete. So let's go and look for what tan theta is. At this point now we can get tan theta. So what are we doing here now is very simple. We know cos theta. So the next thing we are looking for here, if we look for tan, what is tan? Tan is what? Opposites over adjacent. So opposite is what? 3, right? Your adjacent is what? Is 4. So you can see that the answer, the question here given to us is tan theta is equals to this. So we've gotten what tan theta is. Likewise, if you're asked to look for sine theta also, from here you can get your sine because you already have what is opposite. Opposite is what? Is 3 from here, and what is hypotenuse is 5. So you can see that we've been able to get tan, the answer of tan, and we'll also be able to get the answer of sine. So I believe this is very clear. If you find this video very helpful, and do well to subscribe and follow me for more and like this video. Thank you very much. See you come my way again next class.